Let's go over how to identify what kind of reaction these are. So if you notice on everyone, I said like elephant toothpaste, barking dog, yellow precipitate, bubbles, burning magnesium. So all these are the reactions you did in your lab. So let's figure out what they were. Okay. The first step is just counting how many reactants and products you have. So I have one reactant, I have the hydrogen peroxide, and it yielded 2 products. So one reactant, 2 products means that this is decomposition. Breakdown. Ooh, that was really ugly. This one, so again, I'm just going to count my reactants and my products. I have 1, 2 reactants, 1, 2 products. So that means it can be 3 things. It can be single replacement, double replacement, or combustion. So with double replacement, remember you have to have 4 compounds. 2 and 2. Combustion, you have to have oxygen by itself as a reactant. Single replacement, on both sides you have 1 element, 1 compound. So let's count. Magnesium is an element. Hydrochloric acid is a compound. And it yielded hydrogen, which is an element, and magnesium chloride, which is a compound. So I have 1 compound and 1 element on each side. So it means that the barking dog experiment was a single replacement reaction. Moving on down, so this one, I have lead 2 nitrate plus potassium iodide yields potassium nitrate plus lead 2 iodide. So again, I'm going to count. I have 1, 2 reactants, 1, 2 products. So again, I have the same rules. Single replacement, 1 element, 1 compound on both sides. Double replacement, 2 compounds on both sides. Combustion, oxygen as a reactant by itself. If I look, there is no oxygen as a reactant, so therefore I know it cannot be combustion. So I have a compound, a compound, a compound, a compound. So all compounds means that this reaction has to be double replacement. These 2 switch places, so on and so forth. Number 4, I have 1, 2 reactants, 1, 2 products. So again, we have single replacement, double replacement, or combustion. And if I looked on my reactant side, I notice I have oxygen by itself as a reactant, so therefore this has to be combustion. So the last experiment we have, again, I'm going to count my reactants and my products. I have 1, 2 reactants, 1 product. So this is synthesis. I have 2 reactants, 1 product. So it has to be synthesis. Now, those of you who are eagle-eyed notice that it can technically be combustion because it is oxygen. But for right now, we're just going to recall this one mainly as a synthesis reaction.